All right, let's go back our examples, and we're just saying that our expected sign for competition is negative, and population and income is positive. Okay, and actually we do have the real data set. Okay, so let's work with the data set. I already downloaded as e-views, and let me try to working with the result. Okay, so y is my variable, then npi as my x variables. Okay. So this is the result I have. Okay. So if they follow the sign I expected, does it follow the same sign as I expected, as we expected? Yes, negative for n and positive for p and I. Okay, we really didn't talk about. We just say the signs of this coefficient. We didn't really talk about these parts. Okay, the last three columns is all related to hypothesis testing, which we'll covered at chapter 5. Okay, all right, and how does the data fit? How does the data fit? Any information from this output? We can see the R square or just the R square. But for multiple regressions, usually look at adjusted R square instead of R square. Okay? Why? We talk about in chapter 2 that adjusted R square is really R square adjusted by degrees of freedom. Okay, so now you understand what the degrees of freedom here means. They adjusted the degrees of freedom. Remember, you all remember the formulas for adjusted R square? R square is equal to we can use ESS divided by TSS, or equal to 1 minus RSS divided by TSS. And adjusted R square is using these parts. So it's 1 minus RSS divided by TSS, and also divided by their degrees of freedom. Did you remember this TSS? N minus K minus 1. K is the number of X. So how many number of X here? 3 is NPI. And what is this? Is the constant. So means that minus 4. And what's the degrees of freedom of RSS? I'm sorry. This is the mistake I did. N minus K minus 1, and this is N minus 1, right? This is a total number of observations. Then since it is total Y, so the degrees of freedom is N minus 1. And this is the residuals, the degrees of freedom, and N minus K minus 1. So adjusted R square is the original R square adjusted degrees of freedom. Okay? So you can see the R square and adjusted R square here. So it's about 58%. The y, the explanation of the variation of the y can be explained by NPI is about 58%. Okay? So far, this is all we can say about it, what we learned so far. Okay? All right? Okay, so I just show the result here. Okay? And this is just the R square. We just look at. Okay, nothing else? All right? So we finish 3.1, 3.2 about how to follow these 6 steps to do the research. Okay, now let me talk about the 3.3, which is dummy variable. Okay. Okay. Let's see one of the examples, which is also on our textbook. Okay. Now, if I wanted to know the relationship of a teacher's teaching experience with the teacher's income. Okay, salary. I mean teacher's salary. Okay, I like to know the teacher's salary. Okay, and I think the most important factor here is teaching experience. Right? So using just 1x, which is the number of years teaching experience of the ICE teacher, and y will be the income of ICE teacher in dollars. So this is in dollars, this is in year, the measurement unit. Okay? Now, if I want to add one more information, so this is one more information and I add it to, okay, which is the teacher's educational background. And the definition for education, teacher's education background is with or without graduate degree. Now this is high school teachers' data. Okay, so we'd like to see that if the teacher with graduate degrees, and how does that affect the salary, the income? How do you think so? So with or without is not the numerical numbers, right? It's just a quality, it's a status, whether they have this graduate degree or not. Okay? Now, if you want to introduce those kind of information, so this is what we ask. How do we analyze relationship between the income and teaching experience of ICE teachers, incorporating the information of educational background? Okay? So we're saying that we can use dummy variable. Why do we call the dummies? Especially if I want to identify these x variables using, usually I'm using x as a numerical variable. Now this is also x variables, but not numerical. So I denote it as a D to identify with the qualitative variable and the numerical variables. So if I assign it value 0 and 1, and only these two values, do not assign any other numbers, just assign 0 and 1, okay? Depending on whether a specified condition is met. So we wanted to see that whether these teachers with or without graduate degree. Okay, if this teacher with graduate degree, I assign it as 1, then those teachers with graduate degree, I will give you the variable d, and the value is 1. Okay, this is something like this one, okay? Thinking about, when I mention this one, you have to thinking about in a data set. In a data set. So now I have y variables. It's all this teacher's salary in terms of dollars, okay? Then I have the x variable, which is teaching experience, which is in years, okay? Now I have another variable I call it d, which is with or without graduate degree. So if I have the like 5 teachers, I just pretended I have 5 teachers with graduate degree. So in this variables called d, the value of this d is equal to 1. And the rest of them without master's degree is going to be 0, etc., up to the end.
Madam,
Yes.
if you want like to have a value that has like 3 possible values, like 0, 1, and 2, is that also considered as a dummy variable?
No. No. Only 0 and 1. This, I'm going to talk about that later on, okay? When you say 0, 1, 2, well, means that, this is just 2 category, right? With or without means 2 category. Okay, so I'm starting with the easiest one, okay? If I have this using with graduate degree, is 1. Without is 0. So I have only 2 category. Okay, in this case, I just have used only 1 dummy variable. That's enough because the 1 dummy variable identifies 2 category, right? Okay, so another example, just Evan said that if they have 3 category, you mean 0, 1, 2 means 3 category, right? So our example shows this one too. They differentiate the graduate degree into PhD and master's. So now I have 3 category. One is with bachelor degree, with master degree, and also with PhD degree. So think about it. How do you do with the dummy variables if you have 3 category? I just showed that if you have 2 degrees of freedom, 2 category, I use just only 1D to identify 2 category. Then how about 3 category? How do I do it? How do I do it? And which I cannot use another number. I can just use 0 and 1. Yes? Huh? How many dummies? In these examples, if my question is 3 category, how many degrees of how many dummy variables should I use? How many? You asking me or answer questions? Okay. So you are asking me, since now I have 3 category, how many dummy variables do I use? Okay. How about thinking it first? Okay, all of you thinking it first. Tell me how many. Okay, then I'll give you the answer. Okay. Thinking it first, then I'll give you the answer. How do you think? How many category that, those D variables, then I can describe this 3 category. How do I do it? And here, I already mentioned that if I have two categories, then one dummy variable is enough. Okay, then how about three categories? How many dummy variables should I use to explain three categories?
Because D is whether it is a graduate or non-graduate, right?
Yeah,
Now we have extra two variables, which is PhD and master's.
yeah.
Now we are going to use D to describe our PhD and master's. So we can say that if the teacher or the professor is a PhD holder, is 1 without a 7. Then we go to the master's also. If the PhD holder, if the professor has a master's degree, is 1. If not, 0. So we can use the PhD as, let's say, B1, B2. PhD can be our B3, and MA can be our B4.
So how many dummy variables?
We still need 2 dummy variables.
Two. Okay, Max's answer is 2 dummy variable. Only 2 dummy variable can explain 3 category. Then how do we do it? He just explained it. Okay, do you know how he thinks? Well, he is PhD student. So well, he should know better. Much more than you do, right? Okay. And let me explain this one, okay? Before I'm just using one dummy variable, which this one represent those with graduate degree. But now I wanted to identify the graduate degree into PhD and master's. Okay? So in other words, I have bachelor's, master's, and PhD. Therefore, I can use, let me show. I can use D1 and the D2. Okay? D1 identify those teachers with PhD degree. Okay? So for example, is this 1, 2, 3, 4, 5. And the rest of them are zero. So the rest of them, what are they? Those without PhD. Okay? Now I identify another dummy variables, which shows that those who with master's degree. Okay? So those with master degrees, so for example, is this 5? Okay? So in this case, those with PhD is also 0. Because this one identify masters only. Okay? So with these 2 dummies, with these 2 dummy variables, means that when D1 equal to 1, is those who with PhD degree. With D2 equal to 1, means those who with master degree. Then with D1 and D2, all 0, means those who with bachelor's degree. Okay? So in other words, D1 is equal to 1 if PhD. Okay? D2 equal to 1 if master degree. Then D1 and the D2 equal to 0 becomes bachelor's. B-A-C-H, bachelor, O-R, am I right? Is there E here?
Was correct.
This is correct, okay. Okay, it's bachelor's, right? Okay, that's one we're saying that if you have a K category, then you need to have K minus 1 dummy variable. Okay? And this is what we call, usually we call this is a comparison group. How to say that? Is this the reference group? Usually we say this is a reference group. Means the base, those with the 0 is reference group. How do we say in our book? And this is what we wanted to do the experiment. So usually this is experimental group, and this is reference group. Okay, let's see how the book's saying. Okay. Okay. Okay, so the equation turned out to be what? Okay, I'd like to show the equations. Now it's y equal to what? Beta 0 plus beta 1 x n plus beta 2 for d or d1, d2. Okay, let me start from the easiest one. Okay, just one. If I just 2 category. Okay, then this is the original model. Now thinking about this one. When d equal to 1, what does this model become? If d equal to 1, means y equal to beta 0 plus beta 2 plus beta 1x. Right? If d equal to 1, understand what I'm trying to do? And if d equal to 0, means what? Right? So in other words, with this dummy variable, it really represents 2 equations. One is for d equal to 1. The other one is for d equal to 0. And how does this 2 regression related? Look at the expression here. These 2 equations with same slope, right? With same slope, then different intercept. Okay? So how do they show on the graph if I have the x and y here, and if I have the beta 1 slope is positive? How do I show these 2 equations? How do I show these 2 equations? With same slope but different intercept. How does that show? Two parallel lines, right? You see what I'm saying here? One is for d equal to 1. The other one is d equal to 0. Since they do have the same slope but different intercept, isn't this is the intercept? Since our example for y is the teacher's salary, right? D is the teaching experience, so we expect the beta 1 is positive, right? More experience, the salary, the higher the salary, right? So the line should be like positive way, right? And since D1 equal to what the teacher with graduate degree, means that they have higher academic degree, the more money they earn. right? Otherwise, why do they have to get a graduate degree for, right? So we can expect the one with higher degree, the intercept is higher, right? See the difference? So maybe the upper line is for d equal to 1. The lower line is for d equal to 0. Both of them with different intercept, and the D1 with higher intercept, right? Then how do you explain this? How do you explain this meaning of this beta 1 and beta 2? In this case, how do you explain the beta 1? Both of them do have the same beta 1, right? So how do you explain this one? This is measured in year. This is measured in dollars. So how do you interpret the beta 1? We just learned in chapter 1 and chapter 2, right? You have to explain this one in your assignment to me. Okay, next week. What do we interpret the meaning of the beta 1 here? 1 year's teaching, 1 more year's teaching experience. The salary will increase by beta 1. Right? And how do you interpret this beta 2? What's the beta 0 mean here? Since this is the salary, right? This is the teaching experience.
That's the base salary, wage.
Starting salary, right? Starting salary. So in this case, x equal to 0 makes sense. If you don't have any teaching experience, means this is the first year you start to be a teacher. So the starting salary. So since the x equal to 1 makes sense in this equation, so beta 0 will be the starting salary. Okay, so in this case means what? If you have the graduate degree, your starting salary is more than those with just bachelor degree. Okay? This is how we explain the meaning of the dummy variable, which is really different from the numerical variables. So beta 1, beta 0 is just the starting salary. Okay? And beta 2, in this case, explain us the increment of the starting salary compared with the teachers with bachelor's degree and the graduate degree. Okay? So with if you want to provide information which is graphical or qualitative information into the equation, okay, you can incorporate the dummy variable as a variable into the functions, into the equations. Okay? Then this will explain the situation of the qualitative variables. Okay? So there's a term called intercept dummy. Why do we call this as an intercept dummy? Why do we call this variable as an intercept dummy? Because it just affects the intercept value. Intercept is the constant, right? This is called intercept, or we call it constant. That's why officially this is called intercept dummy. And we'll learn this one in later chapter, which is more complicated parts. Okay, now we just bring this dummy variable as one of the variable in the equation only. Okay, in this semester, at the end of this semesters, we will introduce with this D and also the combination with other quantitative variables, and which bring up the more variety situation, okay, of the reality. So this one just show the relationship between these two groups. One is with or without. Even if I have three categories, so we're just saying that we have the D1 and D2, right? So with D1 and D2, so let me show it here. If I have D1, D2, so what does that affect us? So let me write it down, okay? Let me just show it. It's D1 and the D1 and the D2 are all equal to 0, means the person with the teacher with bachelor degree, right? So this one means y equal to beta 0. This one is 0. This one is 0. So plus beta 1 x. Okay, if D1 equal to 1, let me put the parenthesis. We just define the D1 with PhD degree, right? So this is PhD. So I just show the PhD here. Okay, then y will be what? This is 1. This is 0. D2 equal to 1 means masters. Okay, then it becomes to y equal to beta 0, and this is beta 3. Okay, then, this is just like that, right? Okay? What does this equation look like? Same intercept, same slope, right? Therefore, x, y, 1, 2, 3. Okay? Then suppose we're thinking, how do you think the relationship with higher degree and the salary in high school? Yeah, so if we're thinking about the high degree with high salary, okay, then beta 0 should be, beta 1 is always the same in this case. So just only the difference is the starting salary. Although it may not be make sense in reality, but it can be in that way, right? So what does that mean? So means this one is positive, this one is positive, right? And all this beta 2 and beta 3 is compared with what? Compared with beta 0. Okay? Since beta 0 is those teachers with bachelor degrees, starting salary. So with PhD degree, the difference is beta 2. And master's degree is beta 3. So they really compare with those with zeros, means the reference group. Okay, the reference group. So masters compare with the reference. Masters compare with the bachelors. PhD compare with the bachelors. But they do not compare masters and PhD themselves. They all compare with the reference group, which is all dummy variable equal to 0. So you need to know the difference between of this one. If I have just two groups, one of them is a reference group, right? So I use this one to compare with the reference. Now I have three groups. So I use one as a reference. The rest of the two is all compared with the reference. But I do not compare with these two groups. I don't compare with these two. All of these two compare with the reference group. So you need to know how to explain those beta. An assignment, I just give you one dummy only because, our data is male and female. Although you want to thinking about the third possibilities, it's okay too. And that will be the 3 category. Okay? But basically, yes.
In the case of gender, we take the 2 genders, right?
Yeah, 2 gender.
It's not the case of intercept dummy because both, I would say both values mean something, right? It's not like having something and not having it, right? It's having something or having something else. You get what I mean? So for the example of the degree,
Yes.
one you have it.
PhD.
For
Masters.
0, you don't have it. It will be the intercept dummy. That's what you call intercept dummy.
No. When I say intercept dummy, okay, this is called dummy, right? This is called dummy. All these coefficients affect the intercept only. The coefficient of this dummy affect the value of the intercept only, called intercept dummy. Did you see this one? This beta 2.
So what is the difference between dummy and intercept dummy?
Well,
It seems like it's the same thing then.
No. I really, in this chapters, they just introduce intercept dummy. There's one called slope dummy. So we'll talk about that in maybe chapter 6 or chapter 7. Okay? That means the dummy will also affect the slope. So what we call a slope dummy. Nowadays, this dummy doesn't affect the slope, right? They affect the intercept only. Did you see this one? They all have the same slope. So the dummy doesn't affect the value of the slope. Therefore, we call it, intercept the dummy because they just affect the value of the intercept only. So we call it intercept dummy. So when we talk about slope dummy, it's more complicated. So we just started from the easiest one. So far, when we call the dummy, we all call them intercept dummy. But in the future, we are going to talk about more, which is also called slope dummy. Okay? Any questions about this one? This is more complicated, right? But think about it. Think about it, it's okay. Okay, just thinking about the way I did it here. Okay, I think the math parts will explain more clearly, right? If I'm always using the words, no, it's really confused. But if I vividly express my equation here, I think it's more clearly. So, here, for this course, especially in business research, okay, it's not all math oriented. We all incorporate with the art. Yes, there's an arts. And in the future, we're thinking that art's even more confused than the plain math. I would rather deal with all the math instead of art. But in the beginning, when you think that mathematics is difficult, then you would rather to have something, really art. But later you will find out the beauty of the math cannot express in words. Okay? I'll see what else. Okay, this is what I'm trying to say. I have the positive sign here. I have the positive expected sign here, right? And if D, since this is just two groups, so D equal to 1, it becomes to this. And this is our book's equation, 3.5, A and B. So the difference just affect the intercept. Therefore, an intercept dummy variable changes the intercept. Slope remains constant. So slope remains the same.
So what you call the intercept is the coefficient that
this term, this term.
Is the beta 1, beta 2, that's what you call intercept or what?
Yeah.
Oh,
This is called intercept. This is called slope. And also, in some area or in our textbook, okay, or in program, they also call this one as a constant too. So there are two names on it. Intercept or constant reverse the same in mathematics in equation.
Why do we call that intercept and not just like coefficient?
Well, when we say that efficiency, all of them are efficient. Yeah, when we say coefficient, these are coefficient, these are coefficient. You are not able to identify which variable's coefficient or is the constant's coefficient.
Intercept is a subcategory of coefficient, right?
Yeah, in general term, all the betas are called coefficient. But the role of this coefficient in the intercept is intercept. But for the x variables, coefficient from x variables are called slope. In regression analysis or even in math.
So that's a way to categorize the coefficient that we put with dummies and the one we put with slopes, variables. Okay, it's okay.
Well, no.
I wanted to
No,
make
this one is, although this is, all x and d are called x variables, are called independent variables. And the why I identify this d and x, I want to express vividly that x here is a numerical variable, and d is a dummy variable. Okay, and beta 0, beta 1, beta 2 are all coefficient. But beta 0 is intercept. And the beta 1 and beta 2 are slope. because the definition for slope and the intercept are different in mathematically. Okay, and this D, the coefficient of these dummy variables affect only the intercept, since when it equal to 1, the intercept become to this, and it equal to 0, the intercept remain as the before. So actually this is the difference between the intercept of these two groups. Okay, let me see, is there anything? Yeah, so this one we say that actually this is two parallel lines. Okay, with the same slope. Since it is parallel, therefore the slope is the same. Otherwise it won't be parallel, right? But the intercept is different. All right? Okay, this is one fewer dummy variable is constructed than conditions. So means that you have 3 categories. You just have use K3 minus 1. So 1 fewer dummy variables. This is what I'm saying here. Okay? Anything else? Okay. So for dual situations, only 1 dummy variable enter as an independent variable, and the coefficient is interpreted as the effect of included condition relative to the omitted condition. Here the omitted condition means 0, okay? Included condition means equal to 1. So the coefficient interpreted as the effects of this included condition relative to omitted. So therefore I'm saying that the beta, beta, if I use the 3 categories. So beta 2 is interpreted as the effect of those teachers with master degrees relative to bachelor degrees. And beta 3, okay? Oh, I'm sorry. Beta 2 is the one with PhD degrees. Okay, so beta 2 interpreted as the effect of PhD degree relative to bachelor degree, and beta 3 is the effect of the master degree relative to bachelor degree. Okay, anything else? Let me see. Oh, this is another example. Okay, I think let's just start it here for a while, okay? Let's, okay, I think I need to say this one. What do we mean by dummy variable trap? Okay, remember this one? Never to use 2 dummy variables to describe 2 conditions. Only 1 dummy variable is required for 2 conditions, right? If you were to make this mistake, and we call it dummy variable trap, then you will have perfect multicollinearity problem, which we will describe it in chapter 8.1, which is the chapters in next semester. Okay, I think all this topic is all important for all of you, especially work with your field, your major. I mean, your major is more in like accounting, like finance, like international trade, something like this one. This topic is all important for all of you. Okay? Think anything else? Okay, this is another example. I think let me stop here. Any questions for these dummy variables? Would you please go back and review 3.3 in our textbook from page 97 up to 101. Okay?
Last week assignment that you had to go through.
Excuse me?
Oh, no, I think I'm talking about another class, I'm sorry.
Oh, you're talking about another class. Okay. I haven't really put this class assignments in the home assignment area. So I will do that this afternoon. Okay? All right. And that's due next week, 20th. Okay? All right. That's for today. Thank you very much.